Hi students, welcome to my lectures on thermodynamics. In the today's lecture, we are going to discuss about thermodynamic properties in a thermodynamic cycle. In the last class, we were discussing about the reversible and irreversible process. Okay, in the today's class, we are going to prove that the value of a thermodynamic property will be zero, whether it is reversible process or irreversible process. But the values of heat and work requirements will be different if it is a reversible process, will be different if it is an irreversible process. These are the two things we are going to prove. Because if you see that thermodynamic properties such as pressure, volume, temperature, energy, enthalpies, entropies, these are all categorized as a thermodynamic properties. Let us prove that using a PV diagram, the value of the thermodynamic property in a cycle is zero. Whereas work requirements will be different if it is following reversible process, and work requirement will be different if it is following irreversible process using the help of PV diagram. And as you can observe on the board, before I get into the topic, first we need to understand what is a cycle and why it is important in thermodynamic context. If you go through, ever heard of heat engines and refrigerators or air conditioners, these are all work in a cycle. For example, if you talk about the heat engines, what heat engines will do? It will extract the heat and convert to work. Again, the cycle goes on. It will extract the heat and convert to work. The fluid inside this heat engine will periodically, it will go through heating process, cooling process. Again, it is heating process and cooling process. This is called a cycle. Another cycle if we talk about is the air conditioning cycles. What in our houses, what the air conditioners will do? Continuously it will extract the heat from the room and throw the heat to the atmosphere. Again, the fluid inside the refrigerator, what it will do? It will come again, it will take some heat from the room and it will discard the heat to the atmosphere. It is also completely going through a cycle. These are called cycles. If you talk in terms of thermodynamic properties, every property value will come back to the same point every cycle. Okay, that is what we are going to discuss. You can see the PV diagram. I have drawn some curves on the board and you can see the black dotted line and the blue dotted line. Okay, the black dotted line, the cycle means the system comes from the state 1 to state 2. Again, it is going back from the state 2 to the state 1. This is what a cycle means. The black dotted line, we have represented the cycle is a reversible cycle. Again, the blue one, okay, blue also, it will come from the state 1 to state 2 and from state 2 to the state 1. So the black dotted line, let us consider it as a reversible cycle, and the blue one which is a irreversible cycle. That is what this have representation as given. And after the drawing the two cycles, I have designated different areas. Area between these two curves is A1. The area between these two black curves is A2. The area between this black and blue is A3. And the area under this blue, the entire area, is A4. Because these areas will help us to determine heat and work requirements, majorly work requirements. Okay. The blue cycle is called irreversible cycle. The black cycle is called the reversible cycle. Let us prove that whether it is irreversible cycle or reversible cycle, the thermodynamic property value will be zero. If it starts from here, comes to here, again starts from here, comes to here. The property is zero whether it is following the reversible route or irreversible route. Let us talk about this reversible cycle, which is the black one. And if I talk about what is the change in property, let us take the pressure as a thermodynamic property at this moment. Let us prove that the pressure in a cycle, the change in the pressure will be 0. Okay. So that is what I have represented. Delta P, that means change in property of the pressure in a cycle in a reversible process. That is delta P CR, which is nothing but state 1 to state 2, the change in P, and again the change in pressure from state 2 to state 1. So that is what? Change in pressure from 1 to 2. Okay. In this reversible cycle, that is black one, plus change in pressure from again 2 to 1. So what is the change in pressure from 1 to 2? This is 1, this is 2. What is change in pressure? P2 minus P1. That is what? This is P2 minus P1 plus change in pressure from 2 to 1. That means here and here. Always from here to here, this is the final point. This is the initial point in the reverse way. Okay. Then what is the in this coming back to the same position, what is this difference? P1 minus P2. That is what? P1 minus P2. And you can see P2, P2, P1, P1 got cancelled out, and finally the property value in a cycle is 0. Similarly, if you can do for the property which is volume. Okay. Change in volume in a cycle, reversible one, which is change in volume from state 1 to state 2 plus change in volume from state 2 to state 1. If we talk about the change in volume from state 1 to 2, and the difference is V2 minus V1. That is what? The first one, the black one. Okay. And similarly, what is the change in property of volume from 2 to 1? 2 here, 1 here. That means V1 minus V2. If I club together, V2 minus V1 plus V1 minus V2 equal to 0. That means whichever the thermodynamic property you take, whether it's volume, pressure, temperature, internal energy, enthalpies, entropies, okay, all these values will be 0 in a cycle. Okay. But in my second statement, and let us calculate the work in this reversible cycle. Okay. Because displacement work I am talking about. Okay. The work in a cycle, that is reversible one, is equal to minus integral of cycle P dV. Okay. This is the general formula, and why minus I am going to discuss further in my next subsequent lectures. Okay. Presently, keep it granted, if you have to calculate the work, you have to use this formula minus integral P dV. That means in a cycle, what is the total work? And important is, if you considering, because if any engines, I mean if any cycle, if you are taking the work, if for example if a system is changing from state 1 to state 2, if you consider this as a positive, state 2 to state 1 should be negative. Keep in mind. Okay. Okay. In a cycle, that is reversible cycle, what is the net work? Okay. Minus cycle integral P dV. That is nothing but minus 1 to 2. What is the work that has been required from bringing the system from state 1 to state 2, which is nothing but minus integral 1 to 2 P into dV, plus what is the work requirement by taking back the system from state 2 to state 1. Okay. That is nothing but minus integral 2 to 1 P into dV. Okay. And as you know, area under the PV curve is nothing but the integral value. If you consider minus integral 1 to 2 P dV means area under the curve for the system state 1 to 2. Okay. That means 1 to 2. Take only this black line. Okay. Because I am calculating for the reversible cycle. Reversible. For this path from 1 to 2, what is the work? That means area under this entire curve. Okay. This curve. That means area under the curve means A2 plus A3 plus A4. That is why A2 plus A3 plus A4. What is the area under the curve? By taking the system from 2 to 1, that means this 2 to 1, this black curve. Okay, I told you that if you're taking this as a positive, you should take this as a negative. That is where negative symbol has come. What is the area under this black curve? A3 plus A4. That is why A3 plus A4, and total work, net work in this total cycle is only A2. That means between these two curves, the area between these two black curves. Similarly, let us take the example of irreversible cycle, the blue one. Okay, let us calculate the change in the property value. Change in pressure in a cycle, that is irreversible one. Okay, that means delta P from 1 to 2 and delta P from 2 to 1. What is the change in pressure from 1 to 2? Final minus initial. Final means 2, initial. Final means 2, initial is 1. That is nothing but P2 minus P1. Okay, from this reverse one, what is the initial value? Initial value is here, final value is here. That means for the reverse one, the initial value will be P2, final value will be the P1. What will be my delta P? Final minus initial. That is nothing but P1 minus P2. See, all the things got cancelled out, 0. Similarly, if you take it for the volume, okay, example, and for this blue one, initial volume is V1, final volume is V2. For this, the top curve, if you take the reverse curve, the initial value will be V2, final value will be the V1. So if we apply, the first one is V2 minus V1, the second V1 minus V2, again V2 V1 got cancelled out, equal to 0. What you observed here, whether you're talking about the property in a reversible cycle or irreversible cycle, the change in pressure and change in volume are 0 in reversible one, as well as change in property of pressure and volume is equal to 0. Okay, this proves that whether it is a reversible cycle or irreversible cycle, the change in property in a cycle is 0. Okay, let us talk about the work. Okay, just like we have discussed about the work in a cycle, the reversible one is A2. Let us see what is the work in a cycle in an irreversible one. That means you're talking about this blue one. Similarly, integral P dV minus is nothing but 1 to 2, state 1 to state 2 plus state 2 to state 1. If you're taking this as a positive, you have to take this as a negative. What is the area under the curve? 1 to 2 for the blue one. This is the blue one. That means area under the curve means A1 plus A2 plus A3 plus A4. A1 plus A2 plus A3 plus A4 minus, in this reverse one, what is the area under this blue curve? Is only A4. That is why here only A4. So net work in a cycle is A1 plus A2 plus A3. Now you can see the property values are, the change in properties values are 0, but the change in work requirement is different for the reversible one and the irreversible one. And for this case, we have found out the work in a cycle for the irreversible one is greater than the work in a cycle for the reversible one. So that is why, because as we know, the properties are state functions, whereas heat and work are path functions. For the state functions means it depends only on initial state and final state. All the property values in the thermodynamics depends only on initial state and the final state. It won't depend on the way it has come. Okay, so that is why the property values in a cycle is 0. I mean whether it is a reversible one or irreversible one. Okay, the change in property, the change in difference for a state functions, it doesn't matter whether it has followed reversible route or irreversible route, whereas the work requirements for reversible one and irreversible one will be very much different. So that is why heat and work are path functions. That means how it has come from state 1 to state 2. Okay, properties are only state functions. That means it's only initial value and final value. It doesn't matter how this has come. So that is why heat and work are path functions, and all thermodynamic properties are state functions, majority. Okay, I hope now you have understood what is a thermodynamic cycle and what happens to the properties, what happens to state properties, and what happens to the path functions. Okay, let us meet with some new concept. Thank you.